Hey guys, so welcome to the new video. In this video, I'm going to continue the series of multivariable optimization. So I'm going to discuss exercise 17.4. In the previous video, I discussed question 2, part A, B and C of exercise 17.4 of multivariable optimization, mathematics for economic analysis by Sydsaeter and Hammond. In this video, I'm going to move forward and discuss question 2, part D and E. So let's just start now. Question 2 part D says that fx comma y equals 1 minus root x square minus y square plus x square minus 2y square, right? And question 2 says that find all the stationary points of the following functions and examine what the second derivative test says about them. So I've discussed this second derivative test in my previous videos. You can go and check that out. I'm not going to explain the second derivative test again, but just for your reference, I'm going to write it again, right? So the second derivative test essentially says that we have A, B and C, right? So when A is less than 0 and AC minus B square is greater than 0, we have a local maxima. Therefore, our stationary point is a local maxima. Whenever A is greater than 0 and AC minus B square is greater than 0, we have local minima. So our stationary point is a local minima, right? And whenever my AC minus B square is less than 0, then irrespective of the fact that A is greater than 0 or less than 0, whenever my AC minus B square is less than 0, we say that the stationary point is a saddle point. The stationary point is a saddle point, right? And how do we find the stationary point? By equating the partial derivative with 0, right? So the first order partial derivative, when they are 0, we say that we have gotten us a stationary point, and then we check that stationary point using these conditions, right? And whenever AC minus B square is equal to 0, then it's a different case. It can be either a local maxima or a local minima. Either a local maxima or a local minima. But now the question arises, what is A, B and C? So A is basically F11, B is F12, which is equal to F21, and C is F22. And what is F11? F11 is basically the second order partial derivative with respect to x, right? So if I write this will be del by del x of del f by del x equals to del square f by del x whole square. So just finding the second order partial derivative of the function fx comma y with respect to x. And what is C? C is again del by del y of del by del y only, the second order partial derivative with respect to y. Here 1 and 2, one is x and 2 is y, right? 1 is the first variable and x is the second variable. And this is fx comma y. If I write this a bit more clearly, this will be del square f fx comma y and del y whole square, right? This is equal to f22. This is equal to f11, right? And C and B is equal to f12, which is equal to f21 by Young's theorem. You can go and read Young's theorem now. So this is basically del by del y and del by del fx comma y with respect to del by del x, right? So this is 1 2. This is f12, which is also equal to f21. So what is f21? What is f21? F21 is basically del by del x by del f by del y, right? So this is the first page, right? Let me just copy the question. Wait a minute, I had just copied the question, right? Why am I writing it again? what is happening. So sorry. Let me just start solving here only now, right? So this was our question, right? So let's just find the stationary point first. So for finding stationary point, we need to equate fx with 0 and fy with 0. And what is fx? Fx is just f1, which is del f by del x. And similarly, fy is just f2, which is del f by del y. And we need to equate these with 0. So what is fx? Fx is del by del x. Now what is del f? What is f? F is root 1 minus x square minus y square plus x square minus y square, right? So this will give me minus 2x plus 2x, and this will be 0, right? So root 2 1 minus 2x, yes, 2x, yes. So now I need to equate this to 0. And what is fy? Del f by del y, and f is root 1 minus x square minus y square plus x square minus y. Is this minus y square? Wait a minute, this is 2y square. Wait a minute, this is 2y square. Right? Minus 2y square, right? So now this will be minus 4y. This is equal to 0, right? So now this will give me the first, this is the first expression. I need to equate this to 0, and this is the second expression. So equating the first expression to 0 will give me, if I just take 2x common, or let me just cancel 2 and 2 here, and let me also cancel 2 and 2 here. Now I'll just take x common, so minus 1, yes. So if I just take x common by equating fx is equal to 0, if I just take x common, I'll be left with minus 1 upon root 1 minus x square minus y square, and this was plus 2x plus 2 plus 2, so x is common, right? This is equal to 0. So this gives me x is equal to 0, or this expression is equal to 0, right? This gives me x is equal to 0, or this is equal to 0. This implies that minus 1 plus root 1 minus x square minus y square is equal to 0 2 times, right? Yes, so this is equal to 0. Wait a minute, let me just write this clearly. This is equal to 0. So this root goes to the RHS. Root 1 minus x square minus y square is always positive, so it goes on to the RHS and becomes 0, right? Now this will give me 2 root 1 minus x square minus y square is equal to 1, which implies that root 1 minus x square minus y square is equal to half. I hope you guys can see. Sorry, I am writing, my font is very small, so let me just write this a bit more, in a larger font, right? So basically we had 2 into root 1 minus x square minus y square, and this was equal to 1. So 1 minus x square minus y square is equal to 1 by 2 root 1 by 2, and if I just square both the sides, this becomes 1 minus x square minus y square. This is equal to 1 by 4. X square minus y square, x square plus y square is equal to 3 by 4, and this gives me x square plus y square is basically root 3 by 2 whole square, and this is actually the boundary of a circle, right? This equation is actually a boundary of a circle, and the radius is root 3 by 2, right? So the expression that we got from equating the first partial derivative equal to 0, we got x is equal to 0 or x square plus y square is equal to the square of root 3 by 2, right? This or is important, not and. If this was and, then I could have equated x 0 in this, I could have put x is equal to 0 in this equation, and I would have gotten two sets of points, right? But because there is or in between, then I cannot do that, right? I can use this interchangeably, right? I cannot use these both of these conditions simultaneously, right? So I would need to find the other set of conditions, right, from equating the partial derivative with respect to y as 0. So now we are doing this. So let me just, this is this expression, right? We need to equate this to 0, this whole expression. So this gives me minus y upon, so if I just take y common, I'll be left with, right, and this was minus 4, I guess, minus y minus 4, I guess. So if, let me just take minus also common, so minus also comes out and I'm left with 4. This is equal to 0. So this gives me y is equal to 0, and minus also goes on to the other side, right? So I'm left with basically y is equal to 0 or 1 upon root 1 minus x square minus y square plus 4 is equal to 0. This means that 1 upon, if I just take 4 to the RHS, 1 upon 1 minus x square minus y square is equal to minus 4. But is it possible? Is this expression possible? No. We'll reject this. This is rejected. Why? Because this is not possible. 1 upon root of something can never be equal to something negative. Why? Because anything in root is always positive. So root of anything is always positive. So the range, if I just write a function fx is equal to root x, if I just define a function fx is equal to root x, this is x, so fx is equal to root x, the range, the domain of this function is, the domain is basically x greater than equal to 0. And what is the range? The range is x greater than equal to 0, right? The range is x greater, wait a minute, the range is fx greater than equal to 0. So anything in the root will always give me a range as greater than 0. Hence 1 is positive, root of anything is always positive. That means that 1 upon root of anything is always positive, hence it can never be equal to a negative 4, right, or any negative value. So basically 1 upon root 1 minus x square minus y square is always positive, right? Not even equal to 0. Why? Because if this becomes equal to 0, then this will become not defined, this expression will become not defined, right? So this is always equal to 0, or if this tends to infinity, then also it can tend to 0 but not be equal to 0. So this is not related stuff, but just let me write this one condition, that this can never be equal to 0. This can never be equal to 0. Can never happen. 1 upon root of something equal to negative 4 can never happen, hence we reject this. So the only condition that we got by equating fy equal to 0 is y equals to 0. Now I have 3 conditions, basically x is equal to 0, or x square plus y square is equal to root 3 by 2 whole square, and y equal to 0. So I can have one point as 0 comma 0, and I can have 1 point by putting y equals to 0 here, right? I can have x square plus 0, if I just put 0 in place of y, this gives me root 3 by 2 whole square, which means that x is equal to, so this is 3 by 4 plus minus root 3 by 2, right? Plus minus root 3 by 2. Plus minus root 3 by 2. So hence the following points are, my stationary points are root 3 by 2 comma 0 minus root 3 by 2 comma 0. These are my 3 points. Now I'll find the second order partial derivatives. My second order partial derivatives are, so I need to find del by del x of del f by del x, right? And I already had the expression of del f by del x. So I need to differentiate this with respect to x, right? So right. So I need to just find I need to differentiate this function again. So this gives me 1 this becomes so the square of this was half, and the square of this, so 2 and 2 gets cancelled. I'll be left with power 1, right? I'm just applying the quotient rule here. So this becomes square. So the square of a square root becomes gives me the power 1 for the denominator. Now I'll just differentiate this by treating y as a constant, because this is the partial derivative, right? In partial derivative, whenever we are finding the partial derivative of a function with respect to a variable, and if the function consists of two variables, only two variable or variables more than one can be find a partial derivative. Otherwise, it becomes a normal derivative. So in partial derivative, if I'm finding the partial derivative of f with respect to x, so while finding the partial derivative, I'll just perform a normal differentiation, but I'll treat the other variable, which is y in this case, as a constant, right? So that will give me the partial derivative with respect to x. So this means this is -1, this is -1, and this is as it is, 1 minus x square minus y square, and this is negative now, and this gives me minus x, and this becomes 1 by 2 so this becomes 2 root 1 minus x square minus y square, and this is minus, this is basically minus 2x upon 2 root. I don't know if you can see this clearly. I need to write this in a better way. So let me just move this. And this will be minus 2x divided by 2 root 1 minus x square minus y square. I hope you guys can see now. Right? So this expression, this is the expression, and this becomes positive of 2, right? So now if I evaluate fxx at 0, 0, so the first point is my 0, 0, and if I just put in 0, 0 in place of x and y, I'll be left with 0, 0, 0. This expression will become -1. This expression will become -1, and this will become 1, and this will become 0, and this will become 2. So -1 plus 2, 1. So this is my a. So my a which is my f of 1, 1 or f of xx at 0, 0, evaluating at 0, 0 becomes, because 0, 0 is the stationary point that we are testing, right? This is the first stationary point that we are testing, and we're trying to classify it. So a is 0, 0, so this becomes positive 1. Now we are trying to find c. So c is basically evaluating f22 at 0, 0 or fyy at 0, 0. So what is fyy? Del by del y, del f by del y, which is basically, so the same expression as before. Right. So let me just show you how to solve this. This was minus 4y, right? Let me just see. Minus 4y. Right? So this becomes 1 minus x square minus y square. So the square of square root gives me power 1, and this becomes negative 1 root 1 minus x square minus y square, and this becomes negative of negative y, and again this becomes minus 2y and root of 2 root of 1 minus x square minus y square, right? So the simple step that we performed earlier, and this is minus 4. Now evaluating this at 0 comma 0 gives me, this gives me minus 1, this gives me minus 1, and this becomes 0, and this becomes minus 4. So minus 1, and this becomes 1. So minus 1, minus 4. This gives me minus 5. And this is my C. Now, what is my B? B is basically fxy or fyx. So basically f12 or f21. And we have to then evaluate B at 0 comma 0. So what is fxy? Or let's find fyx. Both of these are the same thing, right? So I need to differentiate this expression with respect to y. With respect to x. So we are finding B as fyx, which is basically del by del x of del f by del y, which is del by del x of minus y root 1 minus x square minus y square minus 4y. So this gives me fyx as, so minus y and minus 2x to root 1 minus x square minus y square, and this is 0. And evaluating fyx at 0 comma 0, this gives me 0, because if I put 0 in place of x and y, it gives me 0. So this is basically 0. Now I have this is my B. Wait a minute, this is my B. So my B, so my A was 1, positive 1, my C was minus 5, and my B was 0, which was fyx. We just found this, right? So and the point in question, or the point of concern, or the stationary point that we are talking about right now is 0 comma 0, right? This was the stationary point at which we found these values, right? So if I just try to use my conditions now, so A is equal to 1, positive, and AC minus B square comes out to be 1 into minus 5 minus 0. This is minus 5, which is less than 0, and whenever AC minus B square is less than 0 implies we have a saddle point. So therefore my stationary point 0 comma 0 is a saddle point. Right? Now let me check for the second stationary point, right? So this was our expression of A. Now let me just substitute root 3 by 2 comma 0 here, right? So if I just try to find the value of 1 minus x square minus y square, this is equal to, if I just substitute root 3 by 2, so this is root 3 by 2, and the square of this minus 0, right? So this gives me 1 minus 3 by 4. This is root 1 by 4. So this is positive half. So this was equal to root 1 by 4, or basically the value of 1 minus x square minus y square will turn out to be 1 by 4, and the root of this will be half, because root always gives you a positive value, right? So if I just substitute the value, I'll be left with minus half here, and the square of root 3 by 2, right? So this will give me 3 by 4 and negative sign, and this will give me 1 by 2 divided by 1 by 4 and plus 2. So this is basically minus 3 by 2 minus half. So this is minus 4, so minus 2 and minus 2 and 4 minus 8. Minus 8 plus 2, minus 8 plus 2 gives me minus 6. So A turns out to be minus 6. And let me evaluate the value of this expression at the value of A at fxx at minus root 3 by 2 comma 0 also, because this is our third stationary point, right? So I'm trying to simultaneously calculate the values. So this is question mark. So what is fxx? The value of this, wait a minute, what was this expression? This expression was minus root 1 minus x square minus y square minus x square by root 1 minus x square minus y square, and this is 1 minus x square minus y square power 1 and positive of 2, right? This was my expression. And if I just try to evaluate fxx at minus root 3 by 2 comma 0, this will also give me the same value, minus 6. Why? Because this expression is not changing. If I put minus root 3 by 2 in place of x, and then I find the square of this will come out to be 3 by 4 only, right? So 1 minus 3 by 4 and y is 0, so this will turn out to be the same as the previous expression, right? Because if I just put minus root 3 by 2 and the square of this and 0 whole square, and this is what is this? This is 1 minus x square minus y square, right? So this turns out to be again 1 minus 3 by 4, which is 1 by 4, right? So 1 minus x square minus y square turns out to be 1 by 4 only, right? Just like the previous case, right? Just like the previous case. So A again turns out to be minus 6 only. A again turns out to be minus 6 only, right? So the whole expression is the same previously. This first expression will turn out to be equal to minus 8, and minus 8 plus 2 is minus 6. So we have found out the different A, actually the similar only, for both of these values, root 3 by 2 comma 0 and both of these points, root 3 by 2 comma 0 and minus root 3 by 2 comma 0. Let us evaluate C now. C f y at root 3 by 2 comma 0. So fyy was, let me copy, right? So if I just evaluate this turns out to be, so this expression becomes 0. Why? Because y is 0, and 1 minus x square minus y square we have already found out the value. So now let me just substitute the value. This is equal to C, and this is again, this becomes minus of 1 by 4, sorry, 1 by 2 minus of 1 by 2, and this is 0 plus 0, sorry, minus 0, and this again is equal to 1 by 4. This is minus 4, so 2 and 2 gets cancelled, so this becomes minus 2 minus 4 minus 6. So this turns out to be minus 6. And if I try to find the value of C at minus root 3 by 2 comma 0 also, then also the value turns out to be same, because this expression becomes 0 because y is 0, and this expression remains same because we need to find the square of x, right? So this again gives me 1 by 4 only, right? So 1 minus x square minus y square turns out to be 1 by 4 only, right? So the whole expression becomes the same for the point minus root 3 by 2 comma 0 also, right? So the c is also the same here, right? C is again same, fyy at minus root 3 by 2 comma 0 turns out to be minus 6 only, right? So now we have now we need to find b. So b again, b is fyx, right? So fyx was basically equal to so 2 and 2 gets cancelled. So xy root 1 minus x square minus y square minus 0, right? So xy root 1 minus x square minus y square. Xy root 1 minus x square minus y square, right? So evaluating fyx at so evaluating b fyx at root 3 by 2 comma 0 gives me 0 because y is 0, right? And it's present in the numerator and is in a product with x, right? So this becomes 0, and b fyx at minus root 3 by 2 comma 0 also becomes 0 because again y is 0, right? So ultimately, if I just draw a line here and another line here, so now I have two stationary points, right? So my second stationary point was root 3 by 2 comma 0, and third stationary point was minus root 3 by 2 comma 0. This was my third stationary point, right? So my a turns out to be minus 6 for both of these values. Minus 6. C turns out to be minus 6, right? Minus 6 and minus 6. B turns out to be 0 and 0, right? So finally I can say that A is negative and AC minus B square is positive. 6 and minus 6 becomes 36 and minus 0. So this is basically positive, right? Where my AC minus B square is equal to 36. AC minus B square is equal to 36. So my A is negative and my AC minus B square is positive. Therefore my root 3 by 2 comma 0, which is my stationary point, turns out to be a local max. And my stationary point minus root 3 by 2 comma 0 also turns out to be a local max. Right? And what was my 0 comma 0? My first stationary point 0 comma 0, my first stationary point was a saddle point, right? I thought I'm going to discuss part E also, but I think the video will become a little bit lengthy. That's why I don't want to move on with part E, and I'm thinking of covering part E in the next video, right? So thank you so much, and if you liked the video, if you revised some concepts, if you understood some theorems, if you understood the procedure of how to solve the question, then please like the video, subscribe the channel, share the video, and do put in a comment. Again, it encourages me to put on more and more videos. Also, if you find any discrepancy in my work, please put in a comment or mail me at stats1304@gmail.com. I am open to criticism, and also I'll be putting in my PDF of my working in the description so that you guys can have a look and maybe even revise or revisit the concepts that we have discussed in this video, right? So thank you so much, and I'll see you in the next video. Bye bye.